Chapter or section 4 was about measures of position. The main one was z-score, which was pretty easy. You just take the difference between the x value and the mean and divide by the standard deviation. And z-scores are between well, usually 95% of the data have z-scores between -2 and +2. -2 corresponds to the mean minus 2 standard deviations, and the mean plus 2 standard deviation, or z-score of +2 is the mean plus 2 standard deviations. So it gives you a good idea of the relative position of a data point with respect to the mean and how far away from the mean it is. The thing I was talking about was percentile, and we were looking at this problem. Which data point below is the 40th percentile? So to do the 40th percentile, yeah, now I realized why I was having a problem. I was reading the problem wrong. I was thinking which data point is below the 40th percentile. That was why I was confused. Okay. So now I understand. So my question was not which data point is below the 40th percentile, which point below is the 40th percentile. Okay, I know how to do that, but I was confused. So what you do is you take a set of data and you order it. So if you have a set of data, first thing you have to do is order it from smallest to largest, which is this is already done. And you count the number of data points, which in this case is 11, and then you multiply the number of data points by the percentile in decimal form. So the percentile, 40% is the same as 0.4. So you take 0.4 times 11, which is 4.4, and you always round up. So we round up to the 5th data point. Okay, so that's where I went wrong. So let's erase that. So get all that correct. So we'll say round up here. Round up to 5. So therefore the fifth data point is the 40th percentile. So we go back now with knowing which data point is the 40th percentile, and we count 1, 2, 3, 4, 5. So we can say therefore 25 is the data point corresponding to the 40th percentile. Well, 40th percentile. So it's pretty mechanical how you do that. So let's add another page here and just do a few more percentiles. So if I said, which data point is the 80th percentile. Percentile, question mark. Okay, so again, you take the decimal equivalent of 80%, which is 0.8. You multiply by the number of data points. That will end up being 8.8. So you round up to 9. So what we can say is, so the 80th percentile is the 9th data point. So we just count 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore 40. So which data point is the 80th percentile? It's the 9th data point, which is 40. So the percentiles, you don't have to average any numbers together. You just have to order them, and you have to count. And then you have to multiply by the appropriate decimal equivalent to the percentile. And then count again. So it's just mostly counting. Okay, so that's the procedure. Okay, why don't you guys do the next one? I'll move this so that you can see the data, and you can also see what I did in the previous problem. So if I asked you which data point is associated with the 60th percentile, so look at what I did. It's going to be somewhere between 25 and 40, right? Because those are the 40th percentile was 25, the 80th percentile was 40. You probably think 36 just by if you interpolate it, but go ahead and do the calculation. So I need to do roll. Who's over here? Let me find, while you're doing that, I'm going to look over, see who's in Clifton Forge. You guys can hear me okay, right? Can you guys hear me? Yes. Yeah, okay. So I'm looking at you. I got to see, there's Hayden, there's Amber, right? Not Autumn. I don't know why I was saying Autumn. Okay. There's Abe, Victoria, and okay. It'll come to me here in a second. I'll look at my list. I know who you are. Don't worry. I'm having a senior moment. Okay, let me pull up my, hopefully I don't have grades when I pull up this spreadsheet here. If I do, I'll quickly make it so you can't tell whose it is. Okay, so spring attendance, hopefully here I come with attendance, yep. Okay, so let me do attendance. Abe's there, I don't see Dakota, Amber, Hayden, Matthew, Victoria. Okay, here we have Katie, Zach, Jenna hasn't come. Calvin, Brooklyn, Karina, Summer, Haley. Okay.
Did you record class on Tuesday?
I did not, but I can tell you which class to watch because somebody else didn't watch it yesterday, so I did that research. Okay, so what's the answer, Haley? 36. So it is what we thought it would be. So yeah, because what you do is you take 11 data points times 0.6, which would be 6.6, and you round that up to the 7th. So it's the 7th data point. And if you count 1, 2, 3, 4, 5, 6, 7. So that's 36. Okay, so that's pretty easy. Now the next thing is deciles. So deciles are basically just percentiles. It's the multiples of 10 percentiles. So the first decile is 10%, the second decile is 20%. So all you really have to do is convert deciles to the corresponding percentile and then do the same thing. So that's nothing new. We can just go back. Let's just go back and do the, if we go back to our just previous three examples that we had, this would be the fourth decile because it's the 40th percentile. This would be the sixth decile. And this one would be the 8th decile. So if somebody asked you, and I'm not going to ask you on a test, but if somebody asked you to find what number corresponds to the 8th decile, you just say, oh, that's the 80th percentile, and I just used the same procedure. Okay, so it's nothing to do there. So the first decile is the 10th percentile, etc. Okay, the one that's more important, and you probably have seen this before, is quartiles. So you can break your data up into quarters. So deciles, you break it up into tenths. So And the reason this is important, and it's actually more important than I thought it was until I taught this, well, until I took a class when I was at Westvaco. I'll explain that in a second. But there are three values, which are the quartiles. So it's the 50th percentile, basically the 25th percentile, and the 75th percentile. So you take your data and you split it in half, and then you take each one of those halves and split that in half. So the process of finding quartiles is actually kind of like finding the median. You order the data. The 50th percent, or the second quartile, is the 50th, is the median. And the first quartile is the median of the lower half of the data, and the third quartile is the median of the upper part of the data. And then you have the minimum and you have the maximum. And so we use the minimum, the first quartile, the second quartile, third quartile, and the maximum to draw box plots. Now, I didn't use box plots that much in my personal experience, but a lot of people do use box plots to represent data. Instead of using a histogram, they use a box plot. So we'll talk about how to do that in just a second here. So what we'll do is, well, we're not going to do that because we already just did it. Second decile is 20th percentile. So that's what we're going to do, is finding quartiles. So like I said, what you do is you rank the data from least to greatest. The second quartile is just the median. So if you have an odd number of data points, it's the middle data point. So you take the number of data points, divide by 2, and round up to the next data. If you have an even number of data points, you divide by 2, take that number in the ranking, and the next higher one, and take the average of those two numbers. The first quartile is the median of all items below the median. And the third quartile is the median of all items above the third quartile. I mean the second quartile. So again, we're breaking up the data into 4 parts. And it all requires you to rank the data first. So we'll do a reasonably small data set. We'll show you how to do it online. That's one of the assignments for your project, which I'll probably assign on Tuesday. So I'll send you guys a copy of what the assignment is. We'll also do a computer lab. So the way we're going to do it, because for one thing, the computer lab here is being used during our period, so we can't use the computer lab. So I tried this yesterday, and I think it'll work. They do have some laptops. Now, if you have your own personal laptop, if you could bring that in, I would appreciate it on Tuesday. If you don't worry. They've got 12 laptops. So hopefully, the worst case scenario is two people will share a laptop. But if you bring in your own, that's good, because that's the one you'll be working on to do your project. And we'll basically go through what the assignment requires you to know. There's also a video that goes through another example, so you'll have plenty of help. I just want you, instead of watching me do it, I think you actually doing it yourself would be much more useful. Okay, so how are we going to accomplish this? So, as you know, sometimes it's hard to see what's going on up there, especially when it's a computer. It's a spreadsheet. So I'm going to email you a link, which you will be able to open on your smartphone. Pretty much everybody has a smartphone, and it's small as well. But the nice thing is you can, in this particular app, you can zoom in on the areas that you can't see. And you can also probably still see better than you can see up there. That's kind of fuzzy. So there's an app I want you to download. It's only about 40 megabytes, so hopefully that won't push you over your limit. Hook up to the Wi-Fi so you don't have to use your own hook up to the DSLCC Wi-Fi. I'll send you the link. So I'm going to ask you to download this. It's called Zoom. It's just a web conferencing software, and that way you can have your computer and you can be doing the spreadsheet on your computer and doing all the stuff, and then you can either see it on the screen if you're close enough, or if you're in the back of the room, you can open up what's on the screen on your smartphone and you can look at it and you can see what I'm doing, so you can follow along. So you'll have basically two screens, one screen being your smartphone or this, and the other screen being your computer opening the spreadsheet and doing it yourself. So we'll see how it works. It's not ideal because it's not, smartphone is not as big as a regular screen, but even in the computer lab you wouldn't have two screens. So this, just gives you a way of looking at one and doing it on the other. Okay, so let me show you how this works. We'll come back to that in a second. Let's find the quartile. So here is the data, and you're not going to have time to write all this stuff down. So I'm going to demonstrate it for you. Okay, so here's the data. It says draw a box plot, which we'll do in a second. But before you draw a box plot, you just need to know what the quartile data is. So I'm going to use a spreadsheet to order this, and then I'll put it back on here so we can look at the data in Smartboard. So let me, just bear with me while I do a little Excel manipulation. Okay, so I'll explain what I'm doing here. You won't have to do this. It'll all be set up so you don't have to do this, but you can get an idea of how somebody might handle this. What I want to do is get a column of data, and this data is not in a column. So what I'm going to do is I'm going to paste the data, hopefully, into Word. Okay, so there's my data. I don't know why I put question marks there, so I'll get rid of those. I could just re-enter the data, but okay, so now it's in a Word document, and I'm going to save this as a text file. So let's just put it, let's put it in documents. Okay, so we'll just call it data file. And instead of saving it as a Word document, I'm going to save it as a plain text file. Okay, so save that. And we'll just say OK. Okay. Now I'm going to read that data into Excel. So get external data from text file. And there's my file. And so there's all my data points. They're in a row instead of a column. So the next thing I'm going to do is I'm going to okay, I don't know why it wouldn't let me copy that. Let's try it again. Okay. So I'm going to paste it. So this thing called transpose, and it changes things from a row into a column. Okay. So the hard way would just be to re-enter the data, but I don't want to do that. Okay. So the thing I want to do here is I want to order it from smallest to largest. Again, you could do this manually, but Excel has a feature called sort, and it will sort it according to its magnitude. So now it's ordered, so that way I don't make any mistakes. And now I'm going to take this back, and I'm just going to put it back in my spreadsheet. Okay. So here now inside. Well, actually, let's just do it in the spreadsheet because it's easier to see. So if you actually had it on a paper, you would you'd have a list of numbers. So here's my list of numbers. And in Excel, the nice thing in any spreadsheet is I can assign numbers to each element. So I'm just putting these so that I know how many data points there are, and there are 40 data points. Okay, so this is the 40th data point. It's 1983, and you've got the so we calculated it manually, but now I've got this nice list which has everything perfectly. So the first date is 1860, and the last date was 19 something. So now that I have this listing, we're going to go through the procedure of finding the second quartile and the first and third quartile. So I've got 40 data points, so that's an even number. Okay, so what we'll do is we'll now go back to the smartboard, and we'll put down what we know. So here's the data, and I said there were 40. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 4 is 36 plus 4. Yeah, okay, so there are 40 data points. So here we go. We've got 40 data points, which is even. So to find the median, we take 40 divided by 2, which is 20. So what we do is we average the 20th and 21st data point. So now if we go back to our listing and we go down to the 20th data point, that's 1947, and the 21st is 1948. Okay, so the 20th is 1947, and the 21st is 1948. So the median is equal to 1947 plus 1948 divided by 2, which is 1947.5. Okay. So that's also equal to Q2. Okay. So that's all we've learned new here is that the second quartile is the median. So that's the one step we wouldn't have known how to do up to this point. First thing we did is we took the data points, put them in order. I labeled them so I knew which was the first through the 40th. To find the median of an even number of data points, you take the number of data points, divide by 2. It's that data point plus the next one. So there are 20 data points that are less than this, and there are 20 data points that are greater than that value. Okay. Now the next thing is to find the quartile. So it says, what does it say here? It says the first quartile is the median of all items below the second quartile. So for our case, there are 20 data points below Q2, and there are 20 data points above Q2. Okay, so we'll use these 20 data points to find Q3 and Q1, and we'll use those 20 data points to find Q2. So what we do now is, so which ones are those? Okay, so you take those 20, and they're going to be, it's even also, it's even again. So when you divide 40 by 2, you get 20, which is still even. So the median of the lower 20 data points is you take 20 and divide by 2, which is 10. So you'll take the 10th and 11th data points and you'll average those together. Okay, so let's do that. So we'll say, so since the Q1 calculation involves 20 data points, to find the median, we take 20 divided by 2, which is 10. So Q1 is the average of the 10th and 11th data points. So now we go back to our list of data, and we see what the 10th and 11th are. So the 10th is 1933, and the 11th is 1934. So 10 is 1933, 11 is 1934. So Q1 is going to be 1933.5. It's the average of the two. So that's Q1. So we got Q2, we've got Q1. Now we need to find Q3. So for the same reason, Q3 is we take the top part of the data, and you're like, well, which ones do I use? Well, one thing you could do is you could do this. You could set up your spreadsheet so that you count the first 20 data points. So that was easy. So when we did that, we took 20 divided by 2, we got 10, added 1, so we took the average of these two values. Well, you can do the same thing for the top 20. So what I'm going to do is I'm going to number the top 20, and that'll make it so I just take the 10th and 11th values of the top 20. I took the 10th and 11th values of the bottom 20. So here the 10th value is 1975, and the 11th value is 1976. So that's what I'm going to do. So what we can say is the 10th value of the second 20 numbers is, I already forgot what it was, is 1975, and the other one's 1976. Okay, so that's 1975. The 11th is 1976, and therefore Q3 is going to be equal to 1975.5. So that's the third quartile. So we've got the first quartile, the second quartile, and Q3 is, so we got all the quartiles now. So the five things you need to do a box plot are the minimum, the maximum, and the three quartiles. So we've got the other, to find the minimum and maximum, that's easy because we have already ordered the data. Whoops. So the minimum was 1860. And the maximum was 1983. Okay, so now we got everything we need for a box plot. So now we can go back and talk about box plot. We've got the data for the box plot. Now you're probably thinking, oh, well, yeah, I understand how to do this, but what if it's an odd number of data points to start with? Or what if it's even when you have the first calculation and odd when you have the second calculation? Well, we'll look at that in a second. We'll take that same set of data and we'll remove one data point and see what we would do with that, and then we'll take two data points off and see what we do with that. But for right now, let's look at the box plot. So here's the rules for box plots. Okay, so it says for a given set of data, a box plot or a box and whisker plot consists of a rectangular box positioned above a numerical scale extending from Q1 to Q3 with the value of Q2, the median, indicating within the box, I mean it's inside the box, and with the whiskers line segments extending to the left and right from the box out to the minimum and maximum data values. So now you can see why we needed those 5 values, because these are going to tell us how big the box is. This is going to tell us where to draw a line inside the box, and this one tells us how long to draw the whiskers. And again, we're not going to ask you to do this on a test. You're doing it in a project, so you can look that up. So don't worry about writing everything down. It's in your book. Just what we'll do is we'll do it, and we'll say, okay, I understand. Okay, that's the gist of it. So what I'm going to do is I'm going to move my, what I'm going to do is I'm going to put everything on one sheet here so I don't have to keep bouncing back and forth. So what I need is minimum Q1, Q2, Q3, maximum. Okay, so the minimum was 1860 and 1983. Okay, 1860, 1983. Q2 was 1947.5. What was Q1? 1933.5. And 19. Okay. Okay, so that's the information. Okay, so now we've got the information. Actually, I'm going to move this to the other side so I can have more space to draw my box plot. So there's my data. Okay, so here's how it works. So the project, you do have to do a box plot. Okay, so you've got 2 axes. Here you have the numerical scale. So this one is just, this axis really doesn't do anything. Okay. So what we're going to do is we're going to make up a scale that includes all these values. So I'm going to say, let's start at 1850. And if we go 1900, 1950, 2000. So I just need to break it up into 3 segments here. So it's 1900, 1950, and 2000. Okay, so that'll make it so that I have all those things. And I'm going to draw a line, which I'm going to erase later, but I'm going to put it in here just to have something to use as a basis. This is just where I'm going to put my data points along. So now all I have to do is plot these 5 points. So 1860 would be about there. 1933, well, there's 25. 30 is probably about there. So I'm going to say that's 1933. 1947 is going to be just to the left of 1950, so that's probably going to be there. 1975, that's going to be, well, here's 1950 and 2000, so 1975 is approximately right there. And 1983 is going to be not that much further this way. Okay, so those are the values. I'll write them up here. So this is 1860, 1933.5, 1947.5, 1975.5, and 1983. Okay, so what have I done? I've looked at the range of numbers that I'm trying to represent. I decide on a scale that's going to include all those numbers. Then I just draw this line, which I'm going to erase later, just so I have some place to put my data points as a reference point. And then I plot the 5 numbers. The minimum, Q1, Q2, Q3, maximum. Okay. Now once you do that, then you follow the rest. So it says, for a given set of data, box plot consists of a rectangular box positioned above a numerical scale. Okay, there's your numerical scale. That's above. Extending from Q1 to Q3. So we'll do that first. So we make a box, and you can just use, a lot of times people just hand draw it. It'd be nice if you used a ruler or something like that. So, something like that. You don't want it huge, you don't want it too small. So there's no fix. Oh, I went too far. Sorry. Let's do that again. I want to pay attention to what I'm doing. Okay, so you go from Q1 to Q3. So there it is. Okay. Then it says with the value of Q2 indicating within the box. Okay, what that means is that I just draw a vertical line here where the median is. So that's my median. And then it says draw, what's the next thing it says? And with whiskers, line segments extending to the left and right from the box out to the minimum maximum data value. So I go from here out to there, and I go from there out to there. So those are my whiskers, and then I can remove my little guide because I don't need that anymore. That was just to help me draw things, but it's in the way, and that's it. So that's a box plot. So you can look at that, and one thing is you can see what the median is, which for most data sets is pretty close to the mean. It's not exactly equal to the mean. But the advantage of this whole thing is I'm not adding, dividing anything. I'm just ordering the data and I'm counting. So it's pretty simple. You can kind of see why this median is not centered in the box, because of these. There's a few data points over here that are way different than the other ones. They're not really outliers, but it's not symmetric in the data. We know that 75% of the data points, no, 50% of the data points are between these two. So it kind of gives us an idea of the extent. It's not exactly the range. The range is these data points, but typically these ones in the middle are, if you do have some outliers, this box is not going to be, the position of the box is not going to be affected that much. The median may be affected somewhat. Anyway, so that's how it works. That's a box plot. I have a video showing you how to do that for the project, so you should be able to follow it pretty well. And as I said, I never learned about box plots in engineering. I didn't really use because since I didn't ever hear about them, I hadn't really used them that much. But I found out that in the area of what we would call quality control, which means if you're manufacturing some item and you're testing it to see whether it meets specifications or not, that a lot of the people who did statistics related to that kind of area would use box plots a lot. So I'm just going to show you specific. There's this statistical program, one of the main ones. It's actually Marcus's partner used to work for this company. So it's called Minitab. So I'm going to show you box plot Minitab and some images. So this is something about growing must be some kind of fertilizer. And let me just zoom in a little bit on this so you can see it better. So this was generated using Minitab. In this case, they actually do it vertically instead of horizontally. So the scale is actually on the vertical part, but you can see that they have the same characteristics. You've got a box. So the first quartile is this value, which is about 22, and this third quartile is this value, and the median is that, and then the maximum is this, and the minimum is that. And so they're comparing these three experiments using some grow fast stuff, something called super plant, and not using any fertilizer at all. So you can see that if you looked at the median values, that using the fertilizer did help overall on average. But there's also, you can see that how the boxes overlap between the different sets of data. So you would say, well, that's not clearly different. if you had them such that these boxes didn't, if it was like the box was up here and this one was boxed down there, then you might not even have to do any fancy statistics to see whether it's statistically significant. But in this case, just doing a rough box plot might say, yeah, it's not as clear cut, so I probably need to use some inferential statistics. But people would use those to compare different things. And they're pretty simple, you know. The actual makeup of a box plot is pretty simple. One thing about Excel, doesn't do box plots, so that's, you know, one of the shortcomings of Excel versus a much more expensive statistical package is it doesn't do box plots. It does histograms, but not box plots. Or at least the standard Excel doesn't do that. Okay, let's go back to the question of what do I do if the number of data points is different. So I'm going to do that by just showing you how things would change. So let's get rid of 1983. Okay, so I'm gonna delete this particular and again, the box plot you have to do for the project will be the same number of data points in terms of even, you know, in terms of which way you do it as the example. So don't worry if you don't get everything here, but I'm going to, at least for you guys who are interested in. So remember what we did is before, so let's take this new set of data. So now the new set of data has 39 data points. So remember what we did before was if it was an odd number, to find the median, we take 39 and we divide by 2, which is 19.5, and you round up. So the 20th data point is the median. In this case, we don't have to take an average, we just read it right off the chart. So we go back to our spreadsheet and we say which was the 20th data point, which was 1947. Okay, so there we don't have to do any calculations, just looking off there. So so we can say 20th is 1947, which is now, because it's the median is Q2, it's Q2. Now, if I were to now want to go back and find Q1 and Q3, what I would do is I would order the first 19 data points, because the 20th is the median, so I don't include that. So I'd go all the way up to 19, okay, which is the same numbers. And then I would skip 20, and I would do the next 19. And if I did that correctly, I should get all the way, if I copy this pattern up to the end, I should get 19 data points, which I do. Okay, so you've got 19 points that are above the median, and you've got 19 points that are below the median. So now what we do is we find the median of these first 19. So because 19 is odd again, so if we go back to here, so what we have is 19 below the median, and we have 19 above the median. Before we had 20 below and 20 above, and the median wasn't one of the data points, it was the average of the data points. So now what we're going to do is we're going to find the median of the 19. So you would take 19 divided by 2, which is 9.5, and round up to 10. So Q1 is the 10th data point, because the 10th data point is the median of the first 19 data points. So I go back to my list and I say, which is the 10th data point? It's 1933. So what we can do is, since the 10th data point is 1933, Q1 equals 1933. Likewise, Q3 is the 10th data point of the second 19 data points. So all I have to do now is just go back to my list and find the 10th data point of the second bunch, which is 1975. So since the 10th data point is, I already forgot what it was, 10th data point 1975, Q3 equals 1975. Okay, so that's how you do. If you start off with an odd number, it doesn't matter what number it is. I mean, if you start off with an odd number, you're going to end up with, is that true or not? Or you always end up with an odd, even? No, might not be. Anyway, in this case, it, maybe it is. Anyway, just follow the rules. So if you have in this case, we started with an odd number of data points such that there was a median, which was one particular value. It was the middle value. You take the number of data points, divide by 2, round up. The 20th data point was the middle of all the data points. That's the median, which is Q2. Then we said there were 19 below the median, 19 above the median, so we took the median of these 19 data points. If you take 19 divided by 2, you get 9.5, round that up to 10, so we took the 10th data point of the bottom 19 numbers and the 10th data point of the top 19 numbers, and that's what we did, and we looked those up on our list, and we got the answer. Okay, now, the question is, what do we do if there are 38 data points? So let's take my data race number 39. So now I've got 38 data points. So I'm gonna have to erase that row again here because it's going to be the second row's fine, second column's fine, but this one's wrong. Okay, so 38 data points. So if you take 38 divided by 2, you get a number. So you get 19. So because this is even, that means the median is not going to be one particular number. So we can say, so the median is the average of the 19th and 20th numbers. So we go back to our list and look for the 19th and 20th numbers on our list, which now would be 1944 and 1947. 1944 plus 1947 divided by 2, which is 1945.5. So that's the median, which is Q2. But because this number here is odd and not even, we're going to be able to actually, in this case, find the median. It will be a particular number and not an average of the numbers. So to find the median, we need to average the numbers together. To find Q1 and Q3, we don't need to. So let's just show how that works. So again, the median is between these two. So I guess I didn't need to erase the first 19. So what I do is I'd have 19 numbers below the median and 19 numbers above the median, but the median is not one of the numbers. It's an average of two numbers. So we would go to 19 like that. And instead of skipping one, which is what we did in the previous example, is we would start right here. And we would count 19 again. So if I do that, you'll see when I've got 19 numbers above the median, 19 numbers below the median. The median being 195.5. So because now I have an odd number, the median of the first 19 numbers is going to be the 10th digit again. Same as the last time. It's going to be the 10th one because in both cases I have 19 data points. So let's add a page here. Since I have, let's say, don't put that in there. Since I have 19 data points below the mean, all I do is take 19 divided by 2, which is 9.5, round up. So Q1 is the 10th data point, which is the same as the previous one because I erased the numbers on the top. So I go back to my list and I say, okay, what's the 10th data point? It's 1933. So it's 1933. So Q1 is still 1933, same as the previous problem. And then Q3 is the median of the top 19 data points. And again, because I've already listed those here, I just count to the 10th, go to the 10th data point, which turns out to be 1974. So so Q3 is again the 10th data point, but of the higher. So that was 19. I already forgot. 1973. Is that what it was? 74. 74. Okay. So that's how you handle. Those are the three cases. For your case, I think there are 400 data points. So if you take half of 400, you get 200. So they're all even. So your particular case will be like the first example. But if I gave you 399 data points, then you would do like the second way. And if I gave you 398, then you'd use the third way. So it's all using the appropriate ways of calculating medians for even and odd numbers. It's just each time you end up, the first case we had even and even, the second case we had odd and an odd, and the third case we had even and odd. You can't go from odd to even, so that's why there's only 3 choices instead of 4 choices. So there's the homework for section 4. So now we know how to pretty much do everything for the main project, which is, there's 5 parts for the main project. Again, I'll go over this on Tuesday. There's also one additional thing that's associated with section 5. So we'll cover that. Since we're going to go through an example of everything we've learned so far using a spreadsheet. I probably won't get to that till Thursday to talk. It's talking about normal distributions.
Which video is the last class?
Yeah. I'll have to email it to you. I think it's class 12. Class